we're going to do a little bit of JavaScript coding today. It's okay if you haven't done any JavaScript before. It's relatively straightforward. It's a little bit less complex than something like Java. We'll have some classes, stuff like that. But overall, it shouldn't be too bad. I have a little sort of intro thing as well to sort of the basic JavaScript style programming. So it's mostly what you're familiar with if you've done things with Java before. So the two sort of things that I want to make sure that you have available is the Pixelbox.js library and the GitHub project. So Pixelbox.js, it has an editor, it has a sort of an API to help us sort of draw stuff on the screen and that sort of thing. I know that on Windows, when you go to do the setup, it'll tell you it might be a malicious file. I think that's just because it's not an actual Microsoft installer. It's just sort of an executable that puts something on your system. In essence, what you're actually installing is the editor, and we'll see that here in a second. The actual library itself, you can go to the Pixelbox GitHub page. You can actually just download the library without the editor if that's something that you want to do. Instead of get the editor. The project, the GitHub project, it's here on the first slide, and we can definitely post that in the chat if sort of as more people show up, or if you didn't quite get it down from the slide. This has the starter code, the stuff that we're going to start with, that I'm going to sort of add to. This has the full sort of finished project as well, and it has this presentation. So you'll have sort of everything available for you. It has a short README with a few links to places as well. So hopefully you'll have everything you need to follow along. And if you don't necessarily want to code along with me, that should be fine as well. So before we get going into the actual coding and talking about some of the files and stuff that are there, I just want to mention that you'll need some sort of editor, something that can handle JavaScript ideally. I'm going to be using VS Code. That's what you're going to see when I switch over to my editor. But in principle, you could use it. You could use anything you wanted to, as long as it can open files. So you could use like Notepad even. You'll need Pixelbox.js. It is free. It does sort of bring you to like a little like donation type page when you go to download it, but you don't have to do that. And then obviously the starter code would be quite useful as well. And like I said, this does have the Pixelbox project. I started you off with a little sort of starter map and a few other things. And then obviously it has this presentation as well. So those are the things that you'll probably want to have sort of ready to go before we start programming. Setup-wise, once you have the Pixelbox app running, you can navigate to the directory from that you downloaded from GitHub, and you can actually open the project.pixelbox file. And so that's going to actually open the whole project for you. Again, that includes like a sprite sheet and stuff like that. So this is a file you're looking for when you go to open the actual project itself. And I'm gonna flip over to the actual project here in just a second. But the main things you're gonna see is a small map. It's got sort of a couple rooms. You're gonna see a second map, and I'll show that as well, called fog. And we're gonna use that to do sort of a fog of war type thing. There's a tile set that you can paint with. I did not create the tile set. For those of you that are in the game dev class in the fall, you're going to see my very poor graphic skills. So this actually comes from one of Kenny's sets called MicroRogue. There is a link in the GitHub repo that you can follow to go look at all of his stuff. All his stuff is free and open license and all that kind of stuff. So he's got a lot of cool things there. And then we're going to actually make sure that we can see some debugging info, just in case we mess stuff up. And that's quite common when I'm programming in JavaScript, that we might need to do a little bit of debugging. And then, of course, we will write the code. So we'll follow along with the presentation. And hopefully by the end of the hour, so around 2 o'clock, we'll be done with sort of the basis of this. A little MicroRogue. So let me go to the actual editor itself. So this is essentially what you see once you open up the project. Over here on the right, this is the tile sheet. So there's a whole bunch of tiles in here. We're only going to use a few of them. Specifically, we'll add a character one, we'll have an enemy one, that sort of thing. The map is here. It's set for 64 by 64. Obviously, I'm not using all those tiles. I just created a couple of rooms. And we also have a second map. So this map is just called map. We have a second map called fog, and if I open that one, it's all black. So I'll talk about how we use that to make sort of a fog of war style thing. So this is something that you could just mess around with. There's all sorts of brushes for you to paint stuff. So if I pick on a tile somewhere, I can paint a whole bunch of stuff in. So very easy to create a tile map style sort of visual for your game using this tool. And when you run the program, this is the window that pops up, the stuff that you've drawn in your tile sheet. I mentioned in the slide that you should do debug dev tool. So if I go to debug, I have dev tool here selected. So it has a little filled square. So that, again, that just brings up some of the sort of debugging stuff in case we have any issues. You can turn that off if you want to, but it can be quite useful. Otherwise, if we click run, we should be able to see the, well, for now, it's nothing because we also have that fog map in there and we haven't written any code for stuff. So the window for your game will be here, and the debugging stuff is in this developer tools stuff here. So we will be messing around with sort of both of these as we go through the lecture today. So let's talk about the starter stuff. And I also have a little slide here with the actual sort of description of the little tile set and map area. Okay, so let's do a quick intro to JavaScript first. So as far as things like control flow and creating variables, it's going to look very similar to other languages that you probably used if you've never used JavaScript before. For the most part, for the variable declaration, you're not going to need any types or anything. Most of the time, we're going to use this keyword let. So something like let value equals 0. JavaScript basically figures out what the type is. It would sort of realize that it was an integer here. Control flow, same as other languages that you've used before. I think later on we're going to use like a for each loop, which looks a little bit different. But for the most part, this should be pretty familiar for any of the loop stuff that we might have to write. Functions, we will be writing some functions actually within classes. I don't think we have any outside of classes for this lecture. But if you do need to write a function, you just preface it with function and whatever the name is. There is no return type, but you can still return a value. So you can return whatever you want to from this. Classes are something that was introduced in ECMAScript 6. We will be using classes. That's essentially what all of our sort of main files of this program are going to have in them. When you add a constructor, it's just a sort of a function called constructor. Other functions, they don't need anything at the start of it. You just use the function name. And then to make something like a field in a JavaScript class, you can just do something like this. So this.x equals 0. X is now a field that is part of this class. So what this means is you're going to have this basically everywhere. That's one of the things that I'm not a big fan of in JavaScript. But we're going to see this all over the place. And I'll probably miss this now and then as well. So that's why the debugging stuff is quite useful. So this is essentially what our classes are going to look like. We're going to have essentially like one for the camera and the character and the enemy and stuff like that. So we will be essentially filling in classes as we go along. But sort of overall, the structure will be similar to what you are used to from a language like Java. All right, so Pixelbox.js, it's very minimal. And that's one of the things that I like about it. It's not one of these sort of heavyweight editors and libraries and stuff. It's just, it lets you create some simple graphics. You can create levels with the tile map editor. There is some sound and music sort of editing capabilities as well. You can create a project and then run your game in just one click. You click run and you got it. So it's free, it's open source. You can go to their GitHub page and download a bunch of stuff. A lot of people use this style of library for things like game jams. So there's a couple games here that I put links to. I think the itch.io page has a few more games in there as well. But some of these are just sort of platformer style games. They don't have a lot of sort of buttons you can use. You have sort of the standard left, right, up, down, and then like A, B. So think of it more like a game that you would create for something like Game Boy or something like that. Game Boy or NES or something is sort of the niche that it sort of sits in. There's lots of libraries out there. This is just one that I found and sort of happened to like. There's not a ton of documentation. there are some sort of sample projects that you can go take a look at, and the couple of games that I list here in the slides, their sources all online as well, so you can certainly go take a look at those too. But I find it to be quite useful. Like I said, it's small. You can easily put this stuff up on a web page with essentially without any trouble at all. The project itself already has an index HTML and all the sort of JavaScript stuff necessary for it. So deploying it is super easy. All right, so let's talk about the starter code. There are a few files, with the exception of main. All of them are just representing classes. So main is, of course, where the program is going to start. The main game loop is located here. And this file, main.js, also imports all of our other classes. There's a camera.js. This is relatively small. I've already written this one for you. It takes sort of a lot of tweaking and stuff because you got to deal with things like the screen size you're using and that sort of stuff. So I figured we would just sort of leave that one sort of already finished for you guys. We have a fog.js file. It's going to control what's visible on our map at any moment. We're going to have square visibility around our player. It's not super realistic for sort of square visibility stuff, but it'll be relatively simple for us to do, and it's going to be quite nice if you want to change it in the future. You can just sort of change how the loop sort of goes over this stuff. We have a character sort of class as well. This has all the data, all the methods for interaction within the character, or interaction with the actual player when we move around, and then we have an enemy file as well. The enemy and character files do have some utility code. So I'll explain what it does when we start to fill out those classes. It's mainly things that you would sort of write in your classes in say like a CS2 type class. You would write a method for like equals, right? Maybe you'd write a method for toString. It's sort of that sort of thing. Do a quick calculation, figure out the distance between two objects, for example, and then be able to use that. So most of the utility code looks like that. It's things that would have taken a little bit just more time to do, but the explanation isn't sort of too complicated. So I want to make sure we can get done here in about an hour. So we'll talk about them as we go through the sort of creating these classes, but you won't need to be able to sort of code them yourself since they're already there in the starter code. Okay, so we're going to start with the character class. So we're going to have a few important variables here. We're going to have the tile and the pixel position of the player. We keep both of these around, sort of the row column and the pixel position of the player, because some of the Pixelbox.js library calls need a pixel position to draw the sprite, and some of them need a tile position if you want the number and see what is there. So we're just sort of keep both of them around. You could probably write a function to sort of convert between one or the other, but I think we'll just keep them both as variables. We're going to need some information about the full map, so we know if, say, we're trying to run into a wall or something, so we know not to actually move the character. That sort of gets us to the sprites that are representing immovable objects. So things like walls, or I don't know if you have tables or pots or whatever you're not supposed to be able to move over. We'll have sort of information about that. We are going to have information about enemies as well. This leads to some coupling between enemy and character. Ideally, if you were making a very large project, you would probably want to reduce this coupling as much as possible. For simplicity's sake, I'm going to have it in there because it'll make things a little bit quicker for us to go through all the programming. But and I'll mention a few of those things as we go through. We need to know what sprite represents the actual player itself, and we'll probably have a couple of booleans and ints to help us out. Now, I want to have a quick note here. So I've tried to make the code as understandable as possible. So if you're looking at the starter code, you'll see plenty of like JS doc comment style stuff in there. And of course, even the utility code is all sort of commented like that as well. So it's probably not implemented in the best way possible, in sort of the most efficient way. And as you tend to optimize things, they become a bit less readable. So it may not be implemented in the best way, but at the end, we're going to have sort of a working prototype that you can then add to and change and mess around with. And I'll point out some of those things as we go along as well. So first thing we're going to do is write the constructor for the character. And really, this is just all the variables that we're going to need. So underneath the call for underneath the function for the constructor, we have a sprite number. That's just literally the sprite number in our sprite sheet that represents the character. And when I go back over to the editor, I'll point that out. We're going to use sprite number 4 as our character. It has a few things related to the pixel position and the tile position. This is where we need to know a little bit of information about the size of our actual sprites. So they are 8 by 8 pixels. That's the way that Kenny had made them. So our initial sort of position for this character will be at 1616, which would be row 2, column 2. And so you can see how I do the conversion. Just divide by 8 to get the row column. Whenever the character moves, they're going to move by 8 pixels. We also have information about the map. So here is our sort of full map, and when we get to the main code, we're going to see how this how I send this in there. And then we have an array for the boundary sprites, the sprites that are things that you cannot move through. So you see in here we got like 150, 153, a couple in the 140s. So let me go to the editor. I can click on sprite number 4. So the number that comes up here at the top of our sort of tile sheet window is the actual sprite number. So we're going to use this character as our sprite. And if I come down here to the bottom, here's 144, 145, 147, and so on. So basically, I'm just a list of these sprite numbers. So look here, I've got 144, 145. Those are going to be boundaries. So those are going to be walls. I also have 39 and 40. Those are 2 different pots. So it's 2 to 39 and 40. So it's just a list of the actual sprites that are going to act as boundaries. So it's nothing, I just look at the different sprite numbers. It's nothing sort of special other than the order of the tile sheet. And then we also have a list of the enemies, and this is where some of that coupling stuff potentially could come in. You probably want like some sort of a game manager to sort of help you out with this sort of thing. But for now, we're just going to make sure that the player itself knows about all of the enemies, so it'll make it a little bit easier for us when we do some sort of attacking stuff. So I'm going to go into VS Code. And I'm in the character class right now. So in the starter code, this is essentially what you end up seeing. I've outlined the methods themselves. So you have constructor, we have an update method, we have a move method. There's also an attack method here. And then we have some of the utility codes. So as we use this, I will point some of those out. So in our constructor, every time you see me use this, that means that I'm essentially making a property sort of inside of this constructor. So I'll do something like this dot sprite number, and I'll set that to 4. So that's part, and I'll do that for the rest of them. Obviously, on the slide, it has the actual code as well, so you can certainly follow along with that or follow along with me. So create, yeah. So we'll do row. And this is just going to be the y divided by 8. So this, which I do often, will give you an error when we actually try to run the program. And we'll have a move amount, and that's going to be 8 as well, and a couple more. So we have 2 parameters that come in. So we have map and we have enemies. So this dot map is just going to be the map, and this dot enemies is going to be the enemies. And then I'll make this dot boundary sprites, and this is an array. The JavaScript is very simple at creating arrays. You just need to use these square brackets to do it. So I got these, and it doesn't really matter which ones you make the boundary sprites. It just depends on which sprites you're actually using. So I just have my list of them here, so I don't forget those. You'll see me put semicolons. You don't actually have to do that, but it's habit. So that's our constructor. Our enemy constructor is going to look pretty similar to this. This is a situation where you could probably use some inheritance, but for now, we're just going to sort of try to keep it as simple as possible. So we've got our constructor, so we got all the data that we need. The next piece is going to be the movement. So we want to be able to relatively simple move our character around with the arrow keys. So we're still in the character class. I want to go to the move method. And you see that we have a direction variable that comes in. That's going to just be a string, and we're going to set that up inside of the actual sort of main file, the actual main game loop. We're going to use a method that I've already written for you called getTile. So getTile just looks in the particular direction that you want to move, and it gives you back a tile object if you can move there, or it gives you back null if there is actually no tile in that location. So chosen is going to be a tile itself or null. If it's null, then we're just not going to do anything. We're essentially just going to return from this move method. So chosen is null, then we're done. Move is going to return whether we actually moved or not. That's why I have the return false here. We're going to use this to help us sort of keep a sort of turn-based movement system. So if we move, then the enemies can move. So we're going to return false in this situation if there is actually no tile in the map in the location you're trying to move to. The rest of it is just updating the row and the column, the X and Y pixel position, and we'll actually update the tile as well. So the character is going to know row column, X and Y pixel position, and the actual tile they are on top of. So we'll add a little bit of updating stuff in addition to a little check to make sure we actually have a valid tile. And then essentially after this, we can go to main, add a few things, and we'll be able to move a character around. So back in the character file, in the character class, we're going to add this in. So I'm going to use let here. I'm going to say let chosen. That's my chosen tile. This.getTile. And we're going to send in the direction. So if we look at the getTile further down, it does a few things where it has a switch and it just looks for where you're actually trying to move to. And at the end, it returns back a tile from the map. So you can take a closer look at this, but essentially you're just getting back whichever tile is in the direction that you just press the arrow key for. We'll add in that little check that I mentioned. So if chosen, for whatever reason, comes back as null, then we're just going to return false in that we didn't actually move. And then we'll do all of the updating stuff. So we will have some more ifs here in a moment. And then we're going to actually do the update. So we're going to update our position. So we're going to update, say, the row, and this will just be the chosen.x. That's actually the that'll be the y. It'll be the chosen position, the chosen tile. Its y is actually the row, and this dot column is chosen.x. Then we'll update our specific pixel position, which is that just this dot column times 8 for the x, and this dot row times 8 for the y, just converting it back and forth between pixel and row. And then I'm going to save the tile as well. We may not use this much, but we can at least have it ready for us. So we'll do this.map.get. This is how you get a tile from the actual map itself. And we can do this.call and this.row. It goes column row when you use get. If we moved, if we actually had some movement happen, then we're going to return true. So we know that we moved, and that if any enemies need to move, they can do so as well. All right, so back to the slides. Let's go over to main. Main already has a function outlined, as well as all of the imports that we're actually going to need for this. So the main stuff that we're going to add here is related to this function, this update function. This runs every frame of your game. So this is your main game loop. If you've used things like Unity before, this would be equivalent to the update function in any sort of game objects that you create, anything that derives from a mono behavior. So this is what runs every single frame. So we're going to have some imports. We'll have some sort of setup code right above this function. And then in the function, that's where we're going to have calls to check if we press the key or if we need to draw stuff, that sort of thing. Okay, so we're going to start with grabbing the background. So this is a function call from the actual library itself, getMap. So the map will be brought in, and we're using a string here, map. That's the name of my map in the actual editor. And I'm just going to call that background. I'm going to use this call to paper. So this sort of gives you a solid color background. The 0 here, though, does not represent black. It actually represents one of the colors in our color palette. So I'll point that out in just a moment. And then we're going to create an array of enemies. It's just going to be empty for now, but we will add something to this later. And then I'm going to create a new character. So this will be the player character. Remember, we need a map and we need an array of enemies to create our character object. So that's why we're sending in the background and an array of enemies. So this gets some of the setup stuff ready for us. So let's go in VS Code. Let's go over here to main. I'm going to scroll down. We have our imports. This is so I can actually use those classes from the files from the other files I have. And then I have that export update function. So above the actual main sort of game loop function, this is where I'm going to put in the let background equals get map. And again, this has to be the same. This has to be the string name of the map that's in the editor. And I'm going to do the paper 0. And I'm going to say let enemies equal an empty array. So I have everything I need to get ready for creating the character. I'm going to use the, instead of let, I'm going to use const here. This just means that after I set this, this variable C for my character, that I can't change it to something else. Otherwise, it functions the same way as let. We'll say new character. It's the name of my class, and I'll put in background in here and enemies. So I have this set up. I have a character. It's going to be at pixel location 1616 when it gets drawn into this world. So let's talk about that. Let's talk about drawing all of our stuff, all of our characters and maps and whatever other stuff that we're going to need in the future. How do we do that in this update function? Okay, and then I have a few pop-ups here. It's pretty much just stuff that I sort of talk about. So if you come back and look at this later on, the pop-up should help sort of explain what's going on. All right, so I'm going to create one more variable before the function called moved, and then I'm going to write the code that actually is going to move us. So this btn things, right? I have if btnp.up, and then I do some stuff. So this btn, this is how we figure out if a button was pressed. So Pixelbox.js actually only supports up, down, left, right, A, and B. So like I said at the beginning, kind of like sort of Game Boy type buttons. Button P and button R are checking if it was pressed or released during the current frame. So we're just going to check if it was pressed. If it was pressed during this frame, then it triggers. If we just used btn, which is actually when I was first coding this, that's actually what I started with, it will actually trigger this multiple times depending on how long you hold it down. Whereas button P, btnp, only triggers it once because you can only press it a maximum time of once per frame, unless you're really fast, I guess. So we're going to add this in, and I'll sort of explain what this is going to do as we go through. So we're going to check for a button press. That's basically what this part's for. So up here, I think I used var for this. It shouldn't matter if you use var or not, but I'll be consistent with the slides. So I'm going to have this start out as false. So moved is false, and then we're going to do our checks. So if btnp, so the button was pressed, and oops, nice autocomplete. If the up button was pressed, then we're going to say moved equals character.move and the string up. So remember that the move function gives us back a true or false, whether we moved or not. So that's what we're saving into our moved variable. And then I'm going to put a few else ifs in here for the rest of the buttons. So I'll have btnp dot right, and we'll do the same sort of thing. So I'll probably just copy and paste the rest of these in here and just right. Typically, and those who have been in my classes before know that if you find yourself copying and pasting a bunch of stuff, there's probably a better way to do it. But again, I want to make this as sort of straightforward as to what's going on as possible. So we're going to leave it like this for now. So just make sure to change all of the values here. So we've got up, right, down, and left. So that's getting ready for determining if there was some sort of movement on this actual frame of the game itself, whether you pressed an actual button. So that's the movement piece. This is going to be very common. Any sort of game you would create with this library is going to have something that looks like this. After that, after all of the input stuff, so all the input stuff is here, we're going to have some of the drawing stuff. So the first thing I'm going to do is CLS. This clears the screen. So CLS clears everything so that we can draw everything again. So essentially every frame, we're drawing all of the tiles every single time. Now, the nice thing about Pixelbox.js is that it is very fast at doing this. It is quite nice. And then we're going to draw the background at pixel 0, 0. So in other words, starting in the upper corner, draw the entire background. So it draws a specific object at a specific pixel coordinate. We're going to use the same draw function or the same style of draw function for sprites and stuff as well. So that's why we need to know pixel positions for stuff. We are going to need to write this update function, but it's going to actually be very simple. So let me go back to the code, and right below our movement stuff, we're going to say CLS. So that's going to clear the screen. And then I'm going to say draw, and we're going to draw the background. This is the thing that's going to be sort of the lowest. Anything that we draw after this is going to be placed on top. So you can sort of think of it sort of a layer system. I draw the background first, then I draw any of the sprites I want, and then on top of that, we're going to draw the actual fog map that we'll get to shortly. So there's my draw. And then I'm going to do c.update. Now, we don't have the update function filled out yet in character. So if I go to the character class, we don't have update here yet. But like I said, it's going to be simple. In here, this is where you might put animation stuff if you were going to have some sort of animation. But for us, we have a draw method that I created inside of the character class that just uses this call here. It's a call to sprite, which is essentially drawing a sprite on the screen. You put the sprite number and the X and Y pixel position. So essentially all we're going to write, because I already wrote the draw function for you, all we're going to write is this .draw. So update just draws the actual character. And again, if you wanted to add more stuff in here, you certainly could. Animation type stuff would be common for this. So draw's already there, but it is important. Anything you want to draw on the screen, any of the particular sprites from the sprite sheet, you want to draw on the screen and have them move around or anything, you're going to use a call that looks like this. Then, like I said, for us, update is just going to draw the sprite for us. So back over to update, we're going to use this .draw, and this is how I call functions from within the same class. You do have to use this. It's the reason why this is essentially everywhere in JavaScript. So again, the draw is clear down here at the bottom. So the draw function is right here. So that's what we're actually calling. Okay, so this should draw our character on the screen. Check here. We're going to flip over. Yeah, so we'll add the boundary stuff in just a moment. So let's go back over to the editor itself. The paper 0 that I mentioned a couple slides ago, that comes from this palette PNG. So this palette PNG is literally just an image with 2 pixels. It's got sort of the dark, sort of almost black pixel and a white pixel. So when I say paper 0, it's going to fill all of these spaces in here that don't have actual colors in them or any other tiles in them. It's going to fill all of those with the first color in my palette. So that's why a paper 0 picks from palette.png. So you can put whatever colors you want in here. Typically, they are the same colors that you use in your sprite sheet. So whatever palette you use to create your sprites. So if it was like a Game Boy palette, you'd have the various sort of grayish green style colors that you can have. I think there was like 4 of them in Game Boy. So that'll fill in all the places where we don't have any tiles with that particular paper color. So I think I have everything saved. So let's see what we got here. Okay, so this is what I get. If you want to change the size of this actual window itself, you do that in the project here. You can update the settings to change how big that window actually is. For us, the sort of default size that I have it here is just fine. There are no sort of errors or anything. They would pop up here in the debug window. So essentially, I'm ready to go. As long as this is focused, I should be able to use, I think WASD should, maybe it doesn't work unless you set it. I think you have to set something specific. So it looks like just the arrow keys are what I've got moving around. So I can still run into walls, but if I keep pressing down, for example, along this wall, I actually don't move there. That's because in our actual tile map itself, our actual map, there's no tile there. So it's actually null. And in my code, I said, if the chosen tile I want to move to is null, then don't move. So that's why I can't actually move past any of these walls, because it's actually null outside the walls. The other thing to note is that I can keep moving my character off the screen. There's nothing in here that follows our character around. So that's something we're going to have to change. So the first thing that we're going to do is make it so that our character can't move into walls. So this is where that array of boundary sprites comes in handy. Any of the sprites that we designate as being a boundary that we can't move into, we're just going to check, is the chosen tile, the one that I'm trying to move to, is that a boundary sprite? So I'm going to close out here, head back to the slides. That's what I'm going to do here. So this is our move function inside of our character class. So here's all the get tile stuff, the if chosen is null, here's the actual updating stuff. So we're going to check if the chosen tile is a boundary tile by calling this boundary check method. So this is one that I already wrote for you. It just goes through, it basically just loops through that array that we wrote and checks to see if the tile I'm trying to move to is actually a boundary tile. So if it is a boundary tile, so if we get true back from that, then we're not going to move. We're just going to return false. So similar case if chosen is null. I separated these out. In principle, you could throw this all into one sort of if statement or a switch or something. But in principle, to make this sort of relatively simple, we're just going to have a bunch of ifs in here to do things. So let's go back to the move for our character class. And the if that we're going to throw in is that boundary check. So I'm just going to put it like in the slides, put it right underneath the one for null. So I'm going to say if this dot boundary check, and I'm going to send in chosen. So it's my chosen slide, my chosen tile. If that's true, then we're just going to return false. So the boundary check is down here. It actually does this sprite check thing. I'm not sure why I broke these up, but it just does a sprite check, which again just looks through. It grabs the tile you're trying to move through and essentially just looks and see, is that included inside of the boundary sprites array. So behind the scenes, there's an error. It's there's a loop and stuff that happens with that. So that's all it's doing. So if we go back to our actual game here, we can see that whenever we move, I can no longer move into the actual wall. The doors, those are completely fine, of course, but I can't move into the wall or any sprite number that is within the array that I created. So that is the main thing for the character. In fact, there's not a whole lot more character stuff that we actually need to do, which is definitely kind of nice. Then you have a few pop-ups for what boundary check does. All right, so I already wrote the simple camera for us. Essentially, it just takes a target, which is going to be the player, and it keeps that player within sort of a box. So it's not a tile by tile follow. That can get a little bit annoying if the camera's sort of moving every time the player moves a tile. So it's not a tile by tile follow, but it will sort of keep you within the character within a specific region in the screen. So I'll show you how that works. There's lots of stuff that you can do with this, lots of different ways to handle a camera. So you can play around with some of the code I gave you. You can come up with a different version of this camera if you want to, but essentially all we're going to need to do is something like this. We're going to need to create a camera object. We create a new camera, and the camera takes in a character. So it takes in our player as the target. And then we just need to do camera.update every frame, so that if the player moves out of the region for the camera, then we can switch over and move sort of our camera position. So in the code here, I'll show you the camera class. It deals with some of this sort of screen height and screen width stuff. So it's basically just checking, it's getting the position between the character and the actual camera itself. What is that position? and it's doing some calculations on it, checking to make sure that the player's not in sort of the last third of the screen, that sort of thing. So you can mess around with these values. I've just sort of hard-coded them here because it tended to look good. But this is something you can certainly tweak and play with and see what's going on. In the end, the very last thing it does is actually move the camera to the new position that I actually compute for it. So we're essentially just going to run this every frame. You don't necessarily have to do it every frame. You could do something where it just moves only if the player moves. So that's a way you could save a little bit of performance there. But for our purposes today, it's not going to be not much of a problem. So back in main, underneath the character, I'm going to create a const C or a const camera, and this will be a new camera. And I'm going to send in my player character. That's going to be the target for this camera. And then after I do my update for the actual player character, I'm going to do camera.update. So we're going to call update for our camera, and then we should have this camera sort of move around for us. So if I run this, as I get closer to the edge, the camera is going to shift over. And it'll do this in both the X and the Y direction. So it might be a little bit jarring. You could probably do something where you shift this in sort of a smoother way. But for now, for us, this should work just fine. I have a few other sprites in here. I put a little sort of down staircase. It doesn't do anything at the moment. It's not being checked for anything. But I did put a pot up here in the corner, and because that's in our boundary sprite list, I can't move through it. So that's the benefit of whatever sprites you don't want to be able to move through. You throw them in that list, and your character won't be able to move through them. Okay, so the next piece here, I think, is the fog. So I created two maps when I did this. I created the map that we run our characters around in, and I created the fog map. The fog map is just blank tiles. This sort of black, sort of close to blank tiles. That's it. So what we're going to do is we're going to draw the fog last, which means it's going to be on top of everything. So the draw for the fog is going to be the end of our main update function. Then whenever we move around, or whenever our player moves around, we're actually going to remove the tiles so we can uncover what is underneath. So for example, the player's in some location, all the tiles around that player will actually be set to null in our fog map. So we're actually changing our fog map as we play. When we change the tile to null, then it's not going to draw a tile in that location anymore. And anything underneath will be visible. So this is how you can sort of layer maps on top of each other and sort of change visually what the player actually sees. So I did write the fog class for you. I wanted to make sure we had enough time, and we're definitely sort of getting short on time at the moment. So I want to make sure we had enough time to get to the enemy stuff. So we're just going to throw the fog in, and you can take a look at how the fog works a little bit later on. So we're going to throw this into main here. So I'm going to create the fog first. Put it down here. So we're going to say const fog. This is going to be new fog, and it takes a map, which is going to be our fog map, which I need to create as well. So we're going to say let fog map equal get map fog. So we're going to grab the fog map. We're going to create our fog map. We'll create our fog object. And then down below in the actual update function itself, the very last thing we're going to do is say fog update fog, fog.update fog. And we're going to send in our character. So it'll update the fog based on our player position. And the very last thing is the draw. So we're going to draw the fog map starting at 0, 0. This is only a square fog. So if I come back here, click run, this is only a square sort of visibility, but as I move, it'll uncover. Now, it doesn't recover the areas that I've already explored. That's a design decision that you might want to make. It wouldn't be difficult to do. It's just I didn't put it in there. But as we move, it'll uncover this area that is around our player. And you could do a lot more complicated stuff with this. Make it clear out entire rooms, for example. As soon as you enter the room, you know everything that's in there. So you can make it more complicated. But for now, it's just a 5x5 sort of area. So sort of a 2 on each side of the player. Or maybe it's 3 on each side. So it's some of that. You can mess around with the values inside the fog class if you want to change the actual visibility radius. All right, so we really only have the enemy stuff left. So the nice thing is there's not a whole lot here. It's going to be relatively similar to our actual player character itself. So this is sort of the intermission here. At this point, we've got a working game. You can sort of move around, interactable player character, an environment to move around in that actually means something. So walls and pots and stuff like that. So we still need an enemy and a little bit of AI. There's lots of tweakable stuff here, the fog clearing size, the camera tracking. We can mess around with the enemy AI once we write that. Ultimately, you're going to tweak this game as much as you want. If you're making a sort of a real thing out of this, oftentimes dev studios spend years before and after their game releases tweaking it. All you got to do is look at things like Fallout 76, for example. Not great coming out with, but probably a little bit better in the past year. So this happens all the time. Playtesting, of course, is obviously going to be important, but there's lots of tweakable stuff, and it's always useful when you're making a game to ensure that you have the ability to do these kind of tweaks, because rarely the first time you write some of the stuff it's actually good. Usually you got to mess around with it. Okay, so let's write the enemy. And for the most part, I'm going to take what was in my character constructor and sort of copy and paste it over there, because we need most of the same stuff. But I am going to have a little bit more that the constructor needs. The constructor is going to take a row and a column. That's going to be where we put the enemy. It's going to need to know about the player for the AI to work properly. And we're going to need to know about the map in sort of a similar reason that the player needs to know about the map, because we don't want the enemy sort of walking on walls and stuff like that. So let's go over to the character class. I'm going to copy and paste what I have in there, and then we'll make a couple of changes to it. That way we don't got to sit there and write it all out. So I'm going to take this stuff here. I'm going to move this into the enemy constructor. Now, I didn't put in the parameters for the constructor here, so we are going to have to add those in, and we'll make a couple changes as well. So the sprite number for the enemy is going to be sprite number 20, so it's going to look kind of like a snake. It's going to take in a row, a column, a player, and the map itself. So for the most part, things like the boundary sprites, they might be different for enemies if you don't want them to go through different stuff that maybe the player can, but we're going to leave it the same here. For this dot enemies, we're going to replace that with player, so that we know what the player is actually doing. The map is fine. We don't need to move them out. I'll show you why in a little bit later. And then we're going to change a couple of these here. For the row, we're just going to take it as a row. And for the column, we're just going to take the column. And then the X and the Y are going to be based on the row and the column. So I'm actually going to move them below here. So they'll just be, the X is the column times 8, and the Y is the row times 8. So pretty similar. This would be a good situation to have some inheritance here, maybe some sort of top level sort of entity type class, and then you could make a couple of classes. You wouldn't want sort of steep, sort of deep inheritance to this. You'd probably want just some minimal inheritance to make this work well. But otherwise, I think that's all we need for those. Actually, let's grab the tile as well. So this .tile is this .map.get, and we're going to grab the column and the row here, just so we know what tile we are currently on. So like I said, enemy has pretty much the same data as the character, so again, some inheritance could be useful here. So movement-wise, and this is going to be relatively simple. We're just going to use the Euclidean distance. I already have some of these coded up in the actual enemy class. We're going to use a couple of values to help us out. I'm just going to hard code them, but they're essentially a view distance and an attack distance. So if the player character is within 1 square in the cardinal direction of the enemy, then the enemy would do an attack. for instance. The enemy's not going to move at all unless the player character shows up in a view distance. So whatever view distance the characters, if the character is in the view distance, so the Euclidean distance is within the view distance, then we're going to do a move. So in other words, the enemy's not going to notice the character until the character gets a little bit too close. So to do that, it's going to be relatively simple. We're just going to add a couple of lines for computing the distance between the current enemy tile and the player's tile. So that's why we needed the tile for the player. And then check and see what the distance actually is and sort of how that is going to affect what the enemy player actually does. So I'm going to say let distance. This dot, we're going to use compute distance. This dot tile, so that's the tile the enemy's on, so that's sort of my tile in that sense. And this dot player dot tile. So the distance between those two tiles. If that distance is, say, greater than 5, then we're not going to do anything. We're just going to return. And the move here doesn't return anything specific, so we can just return. If the distance, I'm going to put less than or equal to 1 here. It should just be equal to 1 if it's right next to you in the cardinal direction. But you would do something with attacking. And right now we don't have the attacking stuff filled out, but you would do something for attack. And then you would return. So we're not actually going to do any movement if we can attack. So it's sort of it's an either or, attack or move situation. So then the question is, which tile do we actually move to? If we're going to move, which is the sort of the main thing with this method, where do we actually move to? This is where we're going to look at all the tiles around us, all the possible places that we can move, and whichever one is closer to the player, that's the one we're going to move to. So I wrote this function. It's going to get the closest tile to the actual player of the 4 that are around you, called getTile. So all we have to do in the code is we'll make a variable called chosen. So let chosen equals this dot getTile. So that's one of the tiles that is closest in those around you. If there's a tie, I think it just picks the first one. I think so. I have to look back in the get tile, but it doesn't really matter if there ends up being a tie. And then as long as chosen is not equal to null, so as long as chosen is actually a tile, then we can just move ourselves there. So I can say this dot row equals chosen dot x, this dot column. Actually, the row should be y. Chosen dot x, this dot x, this dot column times 8, and this dot y is this dot row times 8. And we'll make sure to update our tile as well. So this dot map, dot get, this dot column, this dot row. So we're just updating that data related to where we are. So that's how we can actually update our enemy player. So that is here, and I have a few pop-ups for this. So getting the closest tile, updating all of our data. So we just have a tiny bit more to go. We're actually almost done. We have to be able to draw the enemy and create an enemy inside of main, and then we're basically there. So let me hop into here again. I'm going to go back to main, and just like we've done for the rest of our classes, we have a constant, and I'm just going to call it enemy1. Of course, you'd make as many enemies you want for a particular level, and this is just going to be a new enemy. And I'm just going to put it at 618. You could have another way to do this, but just so the column and the row, so 18.6 for the column row, and then put the map as well. So I have the enemies placed in some row column, the character, the player essentially is what I need as a reference, and the map as well. So that creates our enemy. We need to put that enemy inside of our array. So we do that. So enemy 0 equals enemy 1. And then we just need to update our enemy stuff. So after and we'll probably put it, let's put it right after the character not update. So we're going to check if we moved. Then we're going to do a couple of for each loops. So assuming we have tons of enemies, we're going to say enemies dot for each. And this will kind of look like Lambda syntax, but it uses an equals. So it kind of looks like Lambda syntax from Java, but it uses an equals instead. So it's an equals and then a greater than sign, and then a pair of brackets. I'm going to do e.update. So essentially, this is just doing the update function for each enemy in that array. So it's sort of your standard for each loop. So if we moved, if the player moved, then we update all the enemies. And I'm going to set moved equal to false. So we're ready for the next time the player moves. And then after that, so we update all the enemies, but that didn't draw them yet. So now I'm going to say enemies dot for each, so another for each loop. And I'm going to use the same style, the same syntax, and we're going to see e dot draw. Now we haven't written update yet in our enemy class, but that's just going to be move. So if you want to do something else when you update the enemies, maybe they have to reload a ranged weapon or something, then you could always put that in there as well. But for now, it's just going to be move. So in the enemy class, for update, we're going to say move, which should actually be this dot move. Okay, and a few pop-ups, and good. So here is our actual run here, and hopefully we don't come up with too many errors. So here is our player moving around, camera moves, fog moves. As soon as we get close enough to the enemy, then the enemy starts moving towards us. Now, right now, if we move down, our player actually moves into the enemy square. So we can fix that, but since we're just out of time, I'm going to. It actually is fixed inside of the full code, where if we try to move into the square where the enemy's located, then we actually attack the human player. The character actually attacks rather than moves. So that's something that you can certainly add in. But that's sort of the basic for this sort of tile-based sort of using Pixelbox.js. The sky's the limit here. For next steps, we didn't add anything with health or any of the attacking type stuff, so you can certainly do that. There's easy places to throw in attacks. You can create more levels. You can have one large map with a bunch of different sort of separate floors that the player gets teleported between, or you can have multiple maps that just get drawn at the appropriate times. You can implement some better designs. A finite state machine would probably be better to handle turns rather than relying on sort of a moved Boolean. Some inheritance would probably be useful, so you don't have to redo a bunch of code. But hopefully this is sort of relatively simple enough. And with the slides themselves, with the starter code and the full code, I know I went a little bit quick here since we definitely were on sort of a time restricted time. Hopefully with all of this info, hopefully you can expand on this if you want to, or find some other use for the library. Start a different sort of tile-based game and just sort of mess around with it. So yeah, so that's basically it. I hope you guys got a little bit out of this, and if you have questions, you can definitely let me know.